Welcome to this talk, From Shipping Containers to Biotech Labs, which is being held as part of the Entrepreneurship's Festival of Disruptive Thinking. My name is Davide Danovi, and I'm here to open and moderate this conversation with Helene Steiner. It's a great privilege for me. For those not familiar with the Entrepreneurship Institute, they believe that everyone can be entrepreneurial, that entrepreneurial people can help make the world a better place by solving problems to create a healthier, smarter, more equal and sustainable future. And their role is to help all King students, staff and alumni, and also people surrounding our community to develop entrepreneurial mindsets. And without further ado, just one word about myself. I'm a senior lecturer at the Center for Stem Cell Regenerative Medicine, and I head cellular phenotyping at BitBio, a biotech company in Babraham in Cambridge. And I'm very passionate about the sort of space in between academia and biotech. And today we have Helene Steiner, who's CEO and founder of OpenCell. Basically, Helen and her co-founder Thomas decided to make their own kind of incubator for early startup access based on her own experience, and they started with free shipping containers. And Helen is going to tell us the story of this incredible journey. She has a background in industrial design and developing products for biotechnology, and I'm really happy to host her tonight and to hear her story. Thank you so much, Helene.
So first of all, thank you for the lovely introduction, Davide. I'm really excited to be here today and to talk to all of you. As Davide already mentioned, I'm Helene Steiner. I'm the CEO of OpenCell. And OpenCell's goal is to lower the entry barrier to biotechnology and to make life science more accessible. So what we really want is that people with great ideas make them a reality, to kind of phrase it really simply. And all people that come to OpenCell have one thing in common, and that is design for the good using life science. So I think it really nicely fits with the whole idea of this event, and that can reach kind of from more affordable therapeutics to decentralized healthcare to more sustainable solutions for the fashion industry or the built environment. And today I kind of will walk you a little bit through my journey and how we actually built OpenCell, including our rapid response PCR labs that we built because of the whole pandemic. But I thought I actually will start to share a little story of my first day at uni as an industrial designer. And the first question of my professor, which he asked us, was, who in the room thinks that they will be a designer later in life? And everyone was obviously kind of like raising their hands, right? Because that's why everyone was actually here to be an industrial designer later in life. And a little bit shockingly, his response was that not even half of you will be. And not because you can't, but because these next years will introduce you to new disciplines, people, and open up new pathways. And many of you will actually define new roles that don't exist yet. And in fact, actually, I think it's 65% of jobs that students will take don't even exist yet, meaning each of us actually have the chance to define those new roles and the economy around it. And I found this an incredible, empowering statement, which made me lead my own way. So instead of kind of designing furniture, what I originally thought I would do, I created my own role as a designer in life science, which means instead of working with wood and textiles or metal, I'm working with organisms, DNA, RNA, to design solutions that use reproducible resources. And I thought I'd kind of give you a little bit of an example how that might look like. So during my time at MIT, we explored how we can use living organisms such as bacteria to communicate between the human body and the environment. And we used bacteria as a growing living actuator to create a responsive biotextile. So what you actually see in the video that is just playing now, it is a garment that reacts to the wearer's body temperature and sweat and supports the body through controlling these tiny little flaps that open and close regarding to the wearer's need. So to kind of like contextualize that a little bit, let's say you go for a run, and in the beginning, you're pretty cold. It's cold outside right now, right? And in the beginning, your muscles are cold, so you want to be kept warm. But then you start running, your muscles start heating up, and your body starts sweating to actually get rid of the heat. But many clothing actually prevents you from doing that. In that moment, all these tiny little flaps actually are opening up, so your body can get rid of the heat. But then when you stop running, your muscles actually cool down relatively quickly again. In that moment, all these tiny little flaps close again. And the technology that enables this are actually bacteria cells. So they have this incredible ability to like expand and contract depending on the relative humidity in the air. And then through applying those bacteria on a substrate material, we were able to create shape-changing materials. And those cells, called Bacillus subtilis, they are actually edible and extracted from fermented soybeans, also called natto, what is a famous Japanese food. Pretty smelly if anybody hasn't tried it yet, but they can also be found in soil, and it is actually a very common friend in research laboratories. And they can duplicate themselves billions of times overnight, and the exponential growth rate enables the use of such growing actuators on a larger scale, such as clothing. And this exponential growth rate is actually the basis of biomanufacturing, which opens up new ways how we can produce products or materials in the future. But the exciting part for me was as well the sensitivity to its environment. And it opens up these new biological interfaces we can build without the need of embedding electronics. So in our case, we used our own skin as the interface that creates a direct interaction between the human body and the bacteria cell. And the video that you just saw in the background is actually real time. So there's a real fast reaction there. But to engineer this garment, we need the bacteria to actually work together with the human body. So we studied the female and the male heat and sweat map together with New Balance and built a software which enabled us to engineer a fully functional garment by combining the data of the body in combination with the expansion rate of the bacteria cells. So the software creates a simulation and a feedback loop of the designed materials and interactions. And connected then with a hardware platform we built, a bioprinter, we were able to produce a fully functional garment. And this platform, the software, the hardware, together with the materials, enabled us to create products driven by nature. And we created from shape-changing lamps to animated origami to artificial plants. So it really opened up a variety of opportunities. And later on, we were also able to add additional functions and created a shoe that not only changes its shape, regarding the relative humidity, but also can start and stop glowing when needed. Very useful if you like running at night. But the biggest takeaway from this project was that it was really only possible because there was a collaboration of minds and skill sets and fields. And working across disciplines is challenging. And you have to allow that different people lead at different stages a project. And what I often see as a problem is that hierarchies in a project are a little bit too rigid. So often either design or science leads, and in reality, they both need to lead, but at different stages. So the project I kind of showed you, or that the one that I just mentioned, it's a great example of the type of products we might buy in the near future. But what happens often with research projects, like the one I showed you, is that they end with being a great idea. And there are many great ideas out there which could make an impact, but they often really getting stuck in research and will never enter the real world. And one reason for this is that there's no too little space where you can actually go and build a sweater made of bioengineered organisms. So what is really missing in the ecosystem? In my opinion, it's a space where disciplines can meet and collaborate, a space which gives you access to affordable laboratories, a space equipped for biotechnology from the 21st century, and a critical mass to prototype fast and to test your ideas in reality. And because I couldn't find a space like this, I decided to build one myself. So 4 years ago, I decided to leave academia and research together with my co-founder Tom to build OpenCell. And together we found this perfect place, what was an abandoned derelict site in the middle of London, in West London. So over the last 3 years, the team has bootstrapped a WeWork for biotech that gives startups access to hundreds of thousands of pounds worth of equipment just for a few £100 a month. And because we are dealing with quite unconventional companies, we have taken an unconventional approach and decided to turn shipping containers into laboratories to create affordable and modular laboratories. And like any product, you have to test it first to get it right. So we started with 3 containers in June 2018, roughly, and then grew quickly to 20, then to 45, and are having now 70 units that host over 30 biotech companies and many more applying to get more space. And our residents include a wide range of biotech companies, from people that produce reagents to lab-grown foods, biomaterials, to a variety of healthcare companies focusing on personal therapeutics or diagnostics. But then I guess we got hit by the pandemic in early 2020, like everyone else. And we quickly snapped in action after hearing the news that there's a new virus spreading and on its way to Europe. So we decided right that moment in January that we wanted to help or kind of contribute to the scenario. And the genome of the virus got published, I think actually quite early in January 2020. So we organized a hackathon the same weekend to bring together the community to look for solutions, but absolutely no one came, which was the first time for us that nobody showed up at an event. And it was, to be fair, a bit demoralizing, but we were still quite certain that it's important to continue. And the reason why I'm telling you this is don't stop because it didn't work out right away or the first time. And then Will Cannon, just I think 1 or 2 months later, from Opentrons, for the people that don't know, it's a liquid handling robot. He wrote a blog post where he proposed a design using the open source machines to automate PCR testing to bring down the costs. And we read the article on Monday, have been on the BBC, I think the same week or the week after, with a first very rough prototype of an automated PCR lab in a box, which can be brought into any location of need. And that was really a huge, big turn in the project. The same week, then, over 200 volunteers from around the world actually started to contribute from all kinds of disciplines, from engineers to communication designers, software developers, nurses, to really support making it a reality. And I think it was an incredible example of what is possible if academia and industry collaborate. I was just chatting with Davide about it, who was a really important contributor and collaborator there, including many other people from King's College, who really made this project a reality. And key was to act and deliver fast and to make it cost efficient and accessible to everyone. And I guess while most countries decided on a centralized testing strategy, such as the UK, we decided to build mobile labs and went for a decentralized model. So this allows for a larger coverage and brings testing in any location of need. And we really believe that that was actually important to design a system that is decentralized. Then because people tend to get sick in inconvenient locations, and healthcare ultimately is a cottage industry, right? So by bringing the facilities and the skills closer to the people, it provides people with fast access to necessary services and lowers the turnaround time for results. And secondly, a smaller decentralized infrastructure is easier to manage than a large centralized facility. But we designed them in a way that they are all connected and each lab is exactly identical, which makes it easier to train staff quicker, but also to move staff between labs and to adapt protocols remotely and share them with each other, and to minimize the time for validation for each lab, which can take a very, very long time for diagnostics. And surprisingly, the biggest challenge of COVID testing, it wasn't a scientific one. PCR testing is the gold standard for diagnostic testing and also one of the most common processes used in molecular biology. It was really an infrastructure and a logistical challenge. I think ultimately it was a design challenge. There are so many different components that are needed for a single test, from plastic to equipment to reagents. And usability in the real world is really important to us at OpenCell. And the real world involves people, supply chains, equipment. And when people create new technologies around a problem, it often doesn't take that into account. So in the case of a high throughput lab, you need to be able to keep track of each individual sample of a patient, each single component necessary for testing, and that each staff member has done exactly the same over and over and over again. So basically, it's a McDonald's models for diagnostics. And I'm not sure if any one of you watched the film The Founder, but in the film, they show how they optimize the making of a burger by optimizing the architecture of the kitchen. And another inspiration for me is the Frankfurter kitchen. And Lahotsky in 1920s looked at the kitchen in a time where money and space was limited. And she looked at how many kilometers we actually run around the kitchen to get stuff done, right? And wanted to make the kitchen smaller to save money, time, and make it more efficient. And labs are very similar to kitchens in the end. You always follow a recipe, and our lab is built to follow one recipe over and over again, and each time it has to have exactly the same quality. So instead of moving liquid by hand, which is, I guess, the majority you do while working in a lab, we needed to make sure most of the steps are actually automated using liquid handling robots, which move liquids basically from one location to another in a very controlled way, which enabled us actually to squeeze pretty much an entire hospital department into one single shipping container. So one shipping container can test 3,000 people a day. And to be able to keep track of those thousands of samples each day, we built our own software to track each sample from the moment a person gets swabbed until the patient has its result, and track every single step along the way. And what that allows us is to ensure the quality is at its highest standards, and we can identify any problem along the way. Because in the end, you really have to remember behind every single sample is actually a person. But really the key of the project was to make it a reality. And it took us only around 6 months to actually come from the idea to a prototype to a fully manufactured lab that is now one in Pakistan, one in London, and then one in Jersey at the Channel Islands. And since August 2020, so since over a year now, we're actually in charge of the entire testing program on Jersey, the Channel Islands, and have tested every single person that has entered the country in the last year and the community, which is way over 500,000 people now. And it's incredibly rewarding, I have to say, to experience the impact your project can have on others. And we have caught most cases within the first 8 hours entering the country, ultimately protecting people's health. But it was important to us that the project is accessible and helpful for anybody in the world. So we therefore made our entire blueprints of the design and the protocols of our laboratories open source and published them on our webpage, including training videos. So others can actually build their own and optimize it for their own supply chain, for their own budget, and for their own country. So we believe that healthcare has to be accessible by everyone. And that includes the infrastructure and the knowledge about healthcare services. But I guess, testing is now kind of a commodity in most places. And I think every one of us probably had at least one test done. And we started to kind of like live with the virus. So instead of just testing, we have to start looking at the mutations of the virus to be one step ahead and to ensure, our policies and our vaccinations are working. And to do this, we need to pivot just from testing to sequencing, meaning we don't want to know if someone is just infected, but more importantly, we want to monitor the mutations of the virus and how it spreads. So we recently built our newest rapid response lab, which is a sequencing laboratory. And again, speed and turnaround time was key here. We now can detect not only the virus, but which mutation in just after 24 hours. And we used a sequencing device that just fits in the palm of your hand from Oxford Nanopore, the one that you just saw in the video, which was a perfect solution for a decentralized system. And we picked Jersey for our first case study, because it is a perfect example of a place that does not have the infrastructure or knowledge on island, so they would have been dependent on another country, and bringing a technology that is for the greater good to the location of need. So if you're interested in that, watch out for our newest publication, which should come out in the end of November, around our sequencing laboratories and our study. So in summary so far, I think ultimately shipping containers are great, particularly if you need to act fast and if there is no existing infrastructure, right? But they also come with a lot of limitations on what you actually can do. And there's still a massive need for more and better infrastructure for life science in cities, which is the core goal of OpenCell. So the biohotel, which is a new model of OpenCell, is actually a model for flexible and fully serviced lab space for life science companies. And it brings our modular labs indoors and transforms underutilized retail space into valuable laboratory space. And Davide, again, was actually a big inspiration with his stem cell hotel, because I think, you know, hotel for scientists, it would be just absolutely something outstanding. So the first biohotel location is tailored for the needs of diagnostics and therapeutics companies, and keeping with OpenCell's mission to bring down the barriers to entry to biotechnology. Any kind of early stage company, which is investor backed, will be actually able to access the facility free for the first 3 months. So the first biohotel will open mid next year with labs for up to 50 biotechs. And all of our biohotel labs are connected to a virtual twin to plan your experiments, to book and collect the data from your equipment, and monitor the ideal conditions of your lab, you know, such as airflow, temperature, humidity, from home or your office, meaning you can lazily check out your results and analyze your data from your couch at home if you want. And the labs have reproducibility and scalability and regulations at their heart to enable companies to move fast and seamless from R&D to trials to production, because really, I'm so passionate to see great ideas to become reality. And the process of actually getting our PCR labs UCAS accredited was a really important learning experience for us to integrate regulations in every single OpenCell lab. And besides private labs, and the biohotel facility actually provides access to equipment worth hundreds of thousands of pounds, again, just for a few pounds per day, which you can book as easily and flexible as a hotel room. And in keeping with the whole motel model, residents can kind of enjoy biotech flavored services like a cryogenic minibus. We have liquid nitrogen and ultra low temperature freezers. We have lab coat laundry, clinical waste management, and PPE vending machine to make sure you have everything really by hand to focus on your science. And it was actually interesting that over the last years, we have learned that access to consumables can be a huge barrier for the early stage companies. Just signing up can be a challenge. So residents can also enjoy our online store and on-site store, allowing life sciences business to order everything from DNA to syringes to pipette tips on demand. Providing you really everything you need for your experiments. And you can actually already make advantage of our consumable store already by click and collect if you ever run out of anything you need. And speed and convenience was also key there for us, because if there's one thing that a startup doesn't have, it is actually time. And I think that's a big difference to research sometimes. And a big chunk of making life science more accessible is actually telling its story. On our YouTube channel, you will find talks from OpenCell residents and alumni, and it's a great resource to learn how lab-grown meat or dairy is made and to learn about other people in the community. And we also use it to make life science more accessible for the wider public and tell stories that people can relate to, and that sometimes can include food made by Heston Blumenthal. So in short, I guess at OpenCell, we really do love biotech, and we do love telling stories, and we also love hearing from others that feel the same. So don't be shy and reach out to us if anything of that, what I've said, kind of spoke to you, if you have an idea. We'll also check out our jobs page. We're looking for a variety of people to join us at the moment. So let us know if any of that would interest you. And then I'm just left with saying thank you for the lovely opportunity, and I hope you have some interesting questions for me.
Thank you very much, Helene. So while we gather questions from the audience, there's a lot of clapping going on. Maybe I will start with you've touched upon the interactions you had in your journey between academia and industry. And also you've touched upon this idea of the space for a mission-driven endeavor. But actually, a very minority of academic-based projects, for example, are mission-driven. They tend to be either mostly hypothesis-driven or more like in recent times, more data-driven. So I just wanted to ask you, so how much do you think we need a different place for doing this, and how much do you think academia should kind of bring in some of these mission-driven challenges?
Look, I think one doesn't cancel out the other. I think both is actually necessary, right? I think, research where you really kind of like explore something and have a hypothesis and not an application, I think, is important. But I think for what we are focusing on OpenCell is, if you decide to kind of take the step as a business and you want to build a product, then I think you have to really start kind of thinking on like the people who it is for. You have to start thinking about kind of business models. You have to start thinking about like, is it sustainable that I produce? And I'm not only talking about sustainability in the term of environmental friendly, but sustainable. Do I have a sustainable business model? Is there actually a market? Does it create value? And I think for us, who we kind of like built the space for is people that really kind of like push for kind of the product focused businesses, having life science at their heart. And that doesn't mean that other approaches are, not as important. But I think one space that I think is really an important one, where maybe it's a little bit about like the coalition of the two. And I think what we often do there is, where we have more like our events and our hackathons, and where people just give talks and exhibitions, where you kind of like can tickle out a little bit of the people where they're at, and the people maybe can just throw in, the different opinion. And often those conversation starters sometimes actually end up in something productive in the end, and people start working, and maybe it gets more, maybe it doesn't. So I think this coalition of the two fields, I think, or like the two sides of life science, I think is a really exciting one. And I think that's why it was so exciting to work with you, Davide. No, I think it was, we were like this really pushy ones, but was very different, with more like the research approach. There was also Rossio coming in, but it was also pushing the science of it, right?
Yes. No, it was fabulous. And actually, just one follow-up to this before we get into the questions that are popping up. Sometimes it feels like you being an enabler and sort of like an incubator may also limit your bandwidth on a specific project. And on the other hand, maybe sometimes, I mean, I've experienced it myself. There is an element of mission creeping as well when some user push you into a direction that is too far away from where you were sort of conceiving this. So there is a fascinating aspect to it, but like, how do you keep the ship going into the right direction with all these pressures?
To be completely honest, by making a lot of mistakes and learning from my mistakes. kind of like steering along the way. I think, if it hasn't been built before, all you can do is your best effort. And meaning you will always get parts of it wrong. But I think if you always kind of stay open-minded and dynamic, and if you're good, you just have to take the criticism and take it on board and say like, okay, and now let us just, improve that and steer in the next direction. I think that's the only thing really that you can do there, in my opinion.
Fantastic. I'll start picking up some questions from the audience. So do you offer business support as well as facilities for startups? This is Paul Marshall asking.
So at the moment, we don't. I think, one thing that we are not is a traditional accelerator. So, we don't kind of say, we'll make a pitch deck, etc. I think one thing that we do is if people kind of have genuine kind of like questions, we then kind of like, steer people in the right directions who are there. But I think what OpenCell is much more is less than a traditional accelerator. It's kind of a critical mass and a platform. So your neighbors will be actually the best people that can give you advice or you can grow from. A little bit like at uni, right? Often, your kind of colleague or, another student gives you more input than maybe the lecturer. No offense to David, I learned so much from my colleagues. So I think what we actually have is a little bit the cup of sugar idea, where, everybody's a little bit at a different stage or has different skill set or a little bit in a different industry. So it's really about kind of exchanging and being proactive in the community. Said that, I think one thing that we actually kind of like further exploring is nevertheless how we can better support companies that are really at an early stage, which just goes beyond the infrastructure. So any kind of feedback and input there, we always love to hear that.
Great. Paul is saying that's a great answer. Thank you. We have from Lisa Lee Bruske. She's asking what sort of experimental models, what is the range of experimental models available in the shipping container? What kind of lab models can you use? So bacteria we've seen, can you go to any sort of experimental models?
I do think, that's for us really exciting to go see, over the next years how far we can go. But so our first location was, for example, really limited to kind of BSL-1 lab. Reason for that was because we were actually adjusting to a food market, and on the other side was a residential area. And because shipping containers are in the outdoor, we thought it wouldn't have been the right place to do anything beyond. So there was really kind of like focused around molecular biology, and also with limitations that specimen-wise, what you were allowed to work. So for us, the PSB and PCR labs pushed us in a new direction where we had to go, beyond and really look at, BSL-2 plus labs, and also in much more kind of how can we create separate airflows to avoid any cross-contamination. What then was actually a really good foundation when we now look at the biohotel, where we kind of like will go further as well into kind of tissue culture, much more kind of DNA, RNA work. So there you will kind of like see a much diverse kind of like range that you're working with. But yeah, I think one thing that we have learned over the last years, rather than getting too broad, we want to master one and then kind of like go to the next one and make that again working. So the first biohotel will be really kind of like focused around kind of diagnostics, therapeutics, and tissue culture. And then if it's also nice to build a little bit of a community around, a little bit of a topic. And then we would love to also see, how further we can push it in the future.
Great. And Sarah is asking if you can go a little bit more in details about how you went from the idea to the reality of 70 shipping containers. So the process, how did you compel others to see your vision and get investors and startups on board?
It was really kind of a crazy story, to be honest. Like, we just reached out to the council and said, look, there is no space. There's something like that is missing. They showed us then all sorts of different locations, which I think didn't really work. And then one day I got a phone call and it said, like, look, there's this a little bit unusual space. Would you just consider having a look? And we walked into Shepherd's Bush Market, and I was like, oh, Jesus Christ, are you thinking that I can take a market stall for kind of a lab? But then he opened this kind of like black gate, and there was this completely abandoned kind of derelict site with untransferred shipping containers. And then we were like, you know what, actually, why not? That is ideal. Having, you know, separated rooms where you can easily install air, easily install water. And then we just kind of like applied for planning permission. And I tell you one thing, it was not easy. It took us over a year, and it got declined. And it was, you know, there's this really cool GIF where basically there's, I think, a comic figure on a train, and it's driving really fast and it's laying the train tracks while it's driving. That's, I guess, how it feels to be a startup. And I didn't know what I don't know. I had to learn it on the step. And then I learned this. I had a startup before which failed, and what I luckily learned at that one is you need customers if you want to make it work. So in our case, the first thing we focused on is like, how can we get people involved? How can, you know, are there people out there that need that? So we kind of really had this open approach from the beginning. So rather than building it and then saying there it is, we actually made an event out of building the first lab, what was called How to Build a Biolab in 10 Days. So I think that really helped us to just kind of build it step by step with the community, rather than building it and then telling everybody there it is. So yeah, but I guess it's really different for anybody, depending what it is, what you kind of want to build.
And actually, Lisa Lee is saying that now she wants to work in a biotech startup in a shipping container. So but Sarah was also interested in the pivoting points. So if you were to sort of take a couple of like the highest and the lowest point in the roller coaster ride, which days could you share? Like,
my lowest point. Let me think now. I think there's so many, to be honest. It really goes like this, you know.
Yeah.
But I think you also sometimes, in the end, you're really kind of naive and in you know, wearing kind of the same when you just fell in love, kind of like your pink glasses, right? But from time to time, you wake up and you're kind of like, what did I do? And because in the end, you realize it's only your responsibility, right? It's nobody else's responsibility. You can't hand it to anybody. Also, your financial risk is obviously there. So sometimes you wake up and it's like, I don't have a customer. Nobody called me for a week. What do I do now? So I think those are kind of like the simple ones. But then I guess the highs are, if you find somebody who joins you and you kind of like start building out a team and you find like-minded people and you kind of start feeling that it actually gets a machine that starts rolling itself without yourself always having to be the one who kind of pushes it, it's a really exciting moment. And then also kind of seeing it with somebody else uses what you have created and they like it is also something what is, yeah, it's priceless, really.
I think an interesting point is that from one point of view, you need to be different in order to make different things. But from the other point of view, sometimes I mean, hearing you, it one gets almost a kick out of the bravery of being so different and so in your face. So I'm wondering how you market it. Like in my own little experience in the interaction, to me the thing really came to life with the idea of the mobile unit for testing, because that is, you know, that is a situation in which you justify being a shipping container completely. And so I'm wondering, you know, from the point of view of how you pitch your vision, it must always have been a very sort of acrobatic tightrope on a sort of, okay, we're not just hippie and different, we're just there for a reason, because it makes sense.
Look, there I thought that actually the challenging thing there is, you know, if you haven't built it or proven it yet, everybody looks at you a little bit and treats you like that as well, you know, kind of either, you know, as oh, that's maybe, you know, wacky, or like also life science, I guess, is a little bit conservative, so people kind of like, oh, that's kind of a hacking lab, or maybe a community lab. So I think what is an interesting one is like, and that's also why I told this story, how sometimes it doesn't work out and you just have to continue. I think it's the consistency and the belief and telling the stories and kind of making points why it could be a valid option. And sometimes it hits the spot and sometimes it doesn't hit the spot. So I think it is, sorry to say it, it's kind of, there's this phrase of like throwing shit at the wall and sometimes it sticks. It's particular when it comes to marketing and communication, and you just have to be a little bit bold there. And sometimes I guess you also can't take yourself too serious.
No, sure. No, and actually along these lines, Leonardo Esposito asks so would you say that you identified the problem of first utilizing these derelict shipping containers and then formulated a solution of converting them into labs, or did you initially have the idea of creating labs from using shipping containers?
You know what? Very good one. It was actually when we saw the containers, it was really for us actually, why not going for temporary structures? I think it actually, and that's often where it is, it sometimes takes you on roads that you haven't thought about it. We knew that we want to make more affordable labs, and building a building is obviously the out of option, no? So it definitely was a little bit by accident there. And but then it was not just that we took it and then gave it a try. There's this 1 year of like, they actually make case studies and you have to kind of review it. And there was like this click moment, I guess, there where we thought like, it's actually perfect. And I guess then, also we have learned its limitations to it. So how we kind of outgrew it now. And I think that's where we now learned like, that the next step is actually that we have to build our own modular labs, which we then kind of actually move into the indoors, what kind of gives you even more opportunities to kind of like improve as well on it. So rough prototypes are always kind of a little bit of, you kind of stick stuff together.
And there's another question from Sarah, who's asking about how did you nurture the community around the OpenCell project? Do you have any advice about growing community as part of a product or service?
I do think it's the most challenging one, to be honest, because it's something what you can't force, and you can't really design it either. It's something that you just have to let happen. And I think the only thing you can do is kind of create a good foundation for it and let people do their own stuff. So actually, if you control too much, it might look like one, but isn't one. So you just have to let it loose. I think we just did some stuff that might kind of nurtured it and kind of gave people the opportunity to see like, oh, we could do that. So I think, we kind of started the Biodesign Here Now festival, but because of the pandemic now it hasn't happened, but happened for a few years where we kind of brought together, like biodesign, so more kind of like the design side of the life science, and the scientists. So there like a lot of kind of collaborations, discussions started, and often I guess like more tangible objects also kind of like start having more kind of conversations. Then to be honest, like we had like our BM biotech events, kind of a good drink often kind of just brings people together, and some food. So it's actually kind of like the easy tricks. And then we just were really fortunate with the site that we have, because it's really outdoor. It's kind of really like a garden. So it was just a great space, I guess, to play around as well a little bit. But yeah, I think when we tried to force it, it didn't work. And then really we just when we started to more enable it, and I think the storytelling came in really there, then people kind of like saw more how they maybe can contribute to it themselves.
And along these lines, so what prompted you to move out of you mentioned like there's a few things you can't really do in a shipping container, and this is sort of moved into the hotel labs. And also I'm curious about sort of the range of seniority you can attract, because there's often like an animal farm element to these things in a sense. It sounds all very utopic, etc. But then you will need to have some sort of structure in it, and some people like yourself who have a lot more experience than others will kind of. I'm kind of wondering how the future looks like, especially like looking at the biohotel, and in particular whether you'd like some imaging in there as well.
I would love that, and I hope we will catch up on that next week. So I think with the containers, I think there's one as well the location we have, I think if you look at the 70 containers, I think it is great for temporary structure. So one thing we did is we actually made advantage of meanwhile space. So what that is, if it is, there's a new development plan, and it takes, sometimes 5 to 10 years. So, there is underutilized space, which I think is great on kind of building something more affordable workspace. So I think that was really fantastic. So, but there is no long-term element, and I think there was one limitation. The other one is as well with the containers, you really are defined by its size. Yeah, it is actually not practical to kind of combine them, because then you start cutting something up, and it actually would be made more efficient to build your own structure. And what we have seen is that people just grow really quickly in OpenCell, and then you kind of like take 2 containers and 3 containers, and then it is actually not ideal anymore. So for us, how we actually design our modular labs is that they can grow with you. And one thing that is really nice with labs is you still want separate rooms, because you want to have different contamination levels, want to have different defined areas. So that is still perfect. But how we design them, that you can also go from 100 square foot to 1,000 square foot with the new model. So it is also designed that you really can scale with us, and then also obviously the outdoor factor is there's limitations there. If you're kind of like in tissue culture, you can't just walk, the outdoor and then go into the microscope room, etc. So I guess, it allows us to go in a little bit more kind of like the more challenging life sciences as well, where I think there's a lot of need there as well. But one really good point that you mentioned is, and I think I kind of talked about that maybe, or tried to explain it with the virtual labs, is one big chunk what we see with people that join us, particularly at the early stages, they're often not aware about like all the regulations that you have to fulfill. And it's not only regulations from the life science as well. Also, when you start the business, all the insurances, employers insurance, etc., health and safety, but even just like how the heck do you deal with clinical waste or chemical waste, right? University took care of that so far. So our software and our services are really there to kind of like help you, that you tick the boxes from the beginning, and again really kind of like grow and learn from it. So that, because if not, it could get really messy. And I think it's really important that if we open up life science and make it more accessible, that we always do it to the highest standards.
Sure, but like for example, let's take Jersey, Pakistan, and the 2 containers in Imperial. Like, so OpenCell is managing all of them, or like when these units kind of start living a life of their own, they will have management in place, etc.
So Pakistan has a life itself, because I think it's comparing Jersey to Pakistan is a really interesting one, because Jersey, we fully manage it. So the stuff is from us, and we took care of everything. And it was really kind of like, a PCR test on demand. But we speak the language, we have an understanding of the supply chain. So I think it was really well suited. But then with Pakistan, we decided on that it's way better that we give the infrastructure and foundation, but then, for example, the reagents that we use would be way too expensive to be appropriate for Pakistan, right? So there it was much more about where you started looking into Turkey, using their own supply chains, meaning you have to adjust, the protocol. But then also when it comes to staff, you really want to make advantage of the locality. So there was much more sensible that it has a life itself. So it's very different, the two of them.
Great. So we have just a few minutes, so we'll close with this question, which asks, what was your hardest obstacle you have faced as a CEO, and how did you overcome it? And what qualities do you perceive as detrimental to be a great leader?
My biggest obstacle, it's a I have to think about that, but I will answer the second question first. Then I think, I guess as a leader, I think for me, what I have learned is it was a massive change for me, for being used to kind of just, be my own project manager and, kind of taking care of my own project, and I lead myself, to actually be a people manager, where it's fundamentally different, the thing how you have to interact. And I have to say, I found that actually the most challenging one. So maybe I'm actually answering both questions with the same one, because, kind of pulling people in and keeping them engaged and kind of making them, I guess, like communicating what you're trying to achieve. I found that in the beginning incredibly challenging, because I didn't know fully, what OpenCell yet is. And, you kind of like build as you go. And I think that was a really big, in the beginning, really big obstacle, what I had to overcome to learn that. But then I think, it's something really exciting and incredible skill to have, to pull people in, to communicate, to make people excited. Because as I said, it's really kind of like the team that really kind of makes it to this machine. In the end, like the science and the technical aspect, that's what people bring in, but it's then really kind of like the personal aspect as well that are really needed and important.
Perfect. So I will stop before the team stops us all. Let's close on this. Always be mindful of what is expertise, what is management, and what is leadership. And it's been a great pleasure to have you, Helene, and congratulations on the journey. And thank you, everyone, for joining.
Thank you, everyone, for the great questions.
Thank you.